Okay, what we're going to be doing is we're going to be analyzing this function, this cubic function, and sketching its graph. So I put some, how we're going to do that. We're going to find the maximum minimum using the first derivative, points of inflection using the second derivative, y-intercept, and sketching the graph. And for reference purposes, I went ahead and put up something we're going to need in a moment. All right, so do A. Actually, I'm going to leave that space for the answers. So do A. After every step, I'm going to have to erase the board. Okay, space is at a premium. So after every step, I'll put the answers next to it. So after I'm done with A, I'll put the answers to A on the board and erase. Then I'll do B, put its answers there and erase. Then C, put its answers there and erase, or its answer there and erase, and then sketch the graph. Okay? So and then do A. So, possible critical points are at f prime of x equals 0 are possible extrema. Okay? So, 1/3 times 3x squared, that's the derivative of x cubed, plus 2x minus 63, derivative constant is 0. So the whole first derivative would have to equal 0. X squared plus 2x minus 63 equal 0. All right, I'll solve this by factoring. The pair of factors of negative 63 that have the positive 2 are positive 9, negative 7. So, I have x plus 9 equals 0, x minus 7 equals 0. Subtract your 9, and x is negative 9. Add your 7, and x is 7. Now, I want more than locations of possible extreme. I want to know if they are actually extrema. So here's a second derivative test. These represent critical points. Okay, so the first thing I have to do to apply the second derivative test is determine what the second derivative is. And that's f double prime of x equals the derivative of this, 2x and 2. Derivative constant is 0. So f double prime of negative 9 going to move that over a little bit. F double prime of negative 9 is 2 times negative 9 plus 2. Negative 18 plus 2 is negative 16, which is less than 0. That is a max. Okay, this next one, f double prime of 7 will be 2 times 7 plus 2. 14 plus 2 is 16. Greater than 0, that is a min. Okay, and that's wonderful. Okay, I know each of these is now an extremum, but there's more to it than that. I also got to get the points. Points. By the way, there is a broadcast next door. I cannot stop it, so you'll hear, possibly hear noise bleeding in from the next room. Okay? So the points. At x equals 9, negative 9, y equals 1/3 times negative 9 cubed, because you use the original function to find the y coordinates, plus negative 9 squared minus 63 times negative 9 plus 600. Okay? Pardon me while I make sure that actually fits and is somewhat visible. Okay? So this is going to be negative 729 over 3. So negative 9 cubed is negative 729. Negative 729 times 1 divided by 3, negative 243, plus 81 Two minuses will be a plus, multiply together. So 63 times 9, 567, plus 600. $1,005. So this point will be negative 9, 1,005. Okay? Okay, x equals 7. Y equals 1/3 times 7 cubed plus 7 squared minus 63 times 7 plus 600. 7 cubed is 343. 343 times 1 is just 343. And it's going to stay over the 3. That does not reduce. Plus 49. 63 times 7, 441. Plus 600. Okay, so 343 thirds plus 49 minus 441 plus 600 is 322 and 1/3. Actually, I'll put this in proper fraction first. 967 thirds. So that will be 7, comma, 322 and 1/3. Okay, that's what we'll use for graphing purposes. Okay, so the points were negative 9, 1,005, that was our max, and 7, 322 and 1/3. That's our min. Okay, I'm going to have to take all this off the board to do B. Okay, do B. Points of inflection are at f double prime of x equals 0. Okay, and I'll just go through the whole process again. Okay, I already know it's, I know it's already here, but I still want to go, I'll still go through the process. You don't have, you may not necessarily have to. Okay, so f prime of x will be 1/3 times 3x squared plus 2x minus 63. So x squared plus 2x minus 63. Okay, so that's the first derivative. The second derivative is 2x plus 2. The derivative constant is 0. Okay, which is what we got before. Okay, so the point of inflection will be at where the second derivative equals 0. Okay, subtract your 2, subtract your 2, 2x is negative 2. Divide by 2, divide by 2, x is negative 1. Okay? Got to find the matching y for a point of inflection. So I'll plug it in the original function, 1/3 times negative 1 cubed plus negative 1 squared minus 63 times negative 1 plus 600. Okay, negative 1 cubed is negative 1. Negative 1 times 1 is negative 1 over 3. Negative 1/3. Plus 1, negative 1 squared is 1, plus 63, plus 600. So, negative 1/3 plus 1 plus 63 So sorry, this should be, yeah, plus 63 plus 600, 1991 thirds. So negative 1, and I'll use its mixed number for 663 and 2/3. Okay? I'm going to verify that using another trick, another mode on my calculator. Yeah, I got the same answer. Okay, so the point of inflection here is negative 1, 663 and 2/3. Okay, so now I need to do C. C, at the y-intercept, and this is something you should have learned in your algebra classes, y-intercept, x equals 0. Okay? You would have seen this in your algebra classes, but if you forgot, that's a reminder. Okay? X equals 0, y equals 1/3 times 0 cubed plus 0 squared minus 63 times 0 plus 600. Zero plus 0 minus 0 plus 600 is just 600. So 0, 600. Y-intercept, 0, comma, 600. Okay, I've got everything I asked for. So now it's time to sketch the graph. I'm not going to overcommit, okay? I only have y coordinates for 7, negative 9, negative 1, and 0. So those are the only ones that I'm going to label on my x-axis at this point, at this time. Okay, so I got negative 9. So I guess I could make that maybe somewhere over here. Okay, I'll try to be proportional about it. So this would be the equivalent. This is negative 9. This would be the set. This would be a 9 over here. So I'll push it in over here to be 7. Okay. I got negative 1. I guess I could put that about right here. And I got my 0. All right. Now I need to come up with a vertical scaling that accounts for everything between 300 and something to 1,005. I propose to go by hundreds. So 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. Again, just do the best you can if you're using something that's unmeasured. Okay, obviously, if you're given a grid, you'll want to be more precise. I'll go negative 100 for the sake of thoroughness as well, even though nothing goes down there. X, Y. All right, so negative 9, nearly a little bit over, a smidge over 1,000. Okay. 7 and about quarter, I'll do about a quarter of the way between 300 and 400. Negative 1, 600, probably about right here will work. A little bit over the 600, a little bit over halfway between 600 and 700, about 2/3 of the way. Okay, and then 0, 600. Okay, so this is supposed to be a max. This is supposed to be a min. So I'm going to make it look like 1. Okay, it should be a hump. I'm going to make the min look like 1. It should be the tip of a valley. Okay, and then I'm just going to play a nice little game of connect the dots. Okay, and I trust that that is adequate clarification. Okay, if you want, we can make this stretch a little bit longer if you really want. Okay, and that will suffice for. All right, I have a quadratic here. This assumes calculus methods, all right? It assumes calculus knowledge. So I'll go ahead and put example here. So these two don't require any calculus. These two do, okay? So do A. And by the way, I'm going to do each of these parts one at a time. So I'll do A, erase the board, B, erase the board, C, erase the board, D, erase the board. Actually, I might leave previous steps if there's space. Okay? So, A, the y-intercept, x is 0. So y equals 6 times 0 squared minus 34 times 0 plus 45. So 0 minus 0 plus 45 is 45. So that is 0, 45. Okay? All right? I'm going to take this off the board, and I'm going to do the x-intercepts. At the x-intercepts, y is 0. Okay? Well, y is f of x, and f of x is this. So I'm going to be setting this quadratic equal to 0. Okay, it's not factorable. So I'm going to remind everybody of what the quadratic formula is. Okay, so A equals 6, B is negative 34, and C is 45. So, x equals negative 34 plus or minus negative 34 squared minus 4 times 6 times 45. All over 2 times the 6. Okay, I break this up into steps. First, under the radical. Okay, so that's going to be negative 30. I'll just copy this as is. Sorry. Negative 34 squared minus 4 times 6 times 45. So that's what they make calculators for. Negative 34 times negative 34 would be positive 1,156 minus, because there's only one minus in that sequence, 4 times 6 times 45 is 1,080. $76. Second, I simplify the square root of 76. Well, 76 is divisible by the perfect square 4. I'll try it. 76 divided by 4, 19. Okay? 76 divided by 4, 19. So I'll split this up in the square root of 4, square root of 19. I get 2 square root of 19. So third, x equals 34 plus or minus 2 square root of 19 over 12. Okay? I'm going to split this up into two cases, because we want, this needs to be graphable. Okay? So I'll leave it in irrational form first. So actually, I'm just going to, actually, I know I keep changing my mind, but I think I'm going to split this up and do this a different way. So 34 over 12 plus or minus 2 square root of 19 over 12. Okay, I'll do the splitting at the points. Okay, so this will be set, these two are divisible by 2, so this will be 17/6 plus or minus the square root of 19, and 2 twelfths reduces to 1/6. Okay, so the x-intercepts are 17/6 minus square root of 19 over 6, comma 0. And this is going to be 17 plus 19 square root, 17/6 plus 19 square root of 19 over 6, comma 0. All right. Do C. These are possible at f prime of x equals 0. So 2 times 6 is 12. 12x, so this gives me 12x to the first minus 34. The derivative constant is 0. Actually, I think I'm skipping too many steps, so I think I'll do that again. 6 times 2x to the first minus derivative of constant, or derivative of negative 34x would be negative 34, and derivative of constant is 0. So this whole thing equals 0. So 12x minus 34 equals 0. Add your 34. 12x is 34. 12x over 12, divide off that 12, and x equals 17/6. Okay? But I need more than that. I also need the y-coordinate. By the way, I already know it's going to be a max or a min, because quadratics, x squared only take this shape or this shape. Okay? So I know it's a max or min. Okay? So y equals 6 times 17/6 squared minus 34 times 17/6 plus 45. Okay? That's what they make calculators for. I'm going to put the 17/6 in parentheses. Square it. I get 289/36 times the 6. 289/6. Okay, there's only one minus in this, so I'm just going to go ahead and take the minus. 17/6 times 34 minus 289/3 plus 45. So 289/6 minus 289/3 plus 45 is negative 19/6. So this the maximum or minimum is going to be 17/6 negative 19/6. Okay. Now sketch the graph. To sketch the graph, I'm going to need these to be something I can use to graph. Okay. Actually, I am not ready to graph yet. Okay. We determined the first derivative was 12x minus 34. So f prime of x is. So actually, I think I'm just going to do this again. So D, before we can sketch the graph, we're going to need, I need the point of inflection. Okay, so D, point of inflection, points of inflection would be where f double prime of x is 0. Okay, well, f prime of x is 2 times 6 is 12, and x goes down a power to 1, minus 34. I'm going to get rid of that. Okay? So f double prime of x is just 12. 12 never equals 0. Okay? So I'll rephrase it. Okay? So f double prime of x equals 0. So solve f double prime of x equals 0. Well, 12 equals 0. Never. So what does that mean? There's none for this one. So now we're ready to move on to the graph. Okay, so to make these useful, I propose decimal equivalents or mixed number equivalents. So this one, 17/6. This is going to be 2 5/6, comma, 3 1/6, negative 3 1/6. Okay, I'll check the first one again. Yep, 2 5/6. All right, for this one, 17/6 minus 19, square root of 19 divided by 6. Approximately 2.1. Okay. So 17 plus this, so I'll put this in parentheses. 17 over 6 plus the square root of 19 divided by 6. Approximately 3.56. Comma 0. .560. All right, so I think that's adequate for what we have to do. So we need to go as far down as negative 3 and some change, and as high up as 45. I propose a scaling by 5. Okay? So 1, 5, 10, 15, 20, 25, 30, 35, 40, 45. Five, 10, 15, 20, 25, 30, 35, 40. So we know the y-intercept is 0, 45. So I'll go 4 each way to account for the spread of the x's and y's. All right, so negative 5. All right, so I already did 0, 45. I have 2.10. So this is 1, this is 2, so about 2.1 might be about right here. And 3.560. So a little bit over 3.5. After 3.5, a little bit after 3.5. Okay. And then almost to 3, but not quite. Maybe right here. And then down about 3. So maybe about right there. Add 2 close to 5. So if this represents the 5, I guess negative 3 would be about right there. All right. And if we're going to sketch just based on this information, then this is adequate. So just to be on the safe side, I'll also do 2 and 1. So 6. Well, that's fine. This is good enough given the information that we have. Okay, and again, just do the best you can, folks. We're not computers. Okay? I propose to tweak it using the actual values, so 6 times 2 squared minus 34 times 2 plus 45. It's about right. Okay, and then I'll do 1. Uh, 117. 117. But again, the previous sketch would have been fine too. Okay, to reasonable people. Well, maybe not. Maybe I should have said that. To many reasonable people. Okay? All right. And I will let that suffice.